Hi grade 12s. So the last section, now that we have drawn graphs and used basically the applications of derivatives to draw graphs, our last section is optimization. Now, optimization in AP Maths is no different to normal maths. The whole point of optimization is, can you find an expression for whatever you're trying to optimize? So it could be anything, cost, time, surface area, anything. So can you find an expression, and then basically can you minimize or maximize it? And don't forget that in order to find the minimum or the maximum, you basically find the derivative and set it equal to 0. So I'm just going to say dy dx, but basically my derivative and set it equal to 0. Now that's exactly the same concept that we use in normal maths. So the only difference here in AP Maths is that the questions are more difficult. So let's look at, we're going to look at 3 examples. Let's look at the first one. Determine 2 positive numbers whose sum is 4. Okay, so first information I know, I'm just going to make the one number x and the other number y, and the sum is 4. Now, don't, normal maths, people start guessing. Okay, so it could be 3 and 1, or 2 and 2, or 4 and 0, but 0 is not positive. They said 2 positive numbers. They didn't say integers. So these could be any real numbers, which means you can't start guessing, because you can't possibly work out all the combination of real numbers that add to give you 4, because there's infinitely many. So don't get drawn into the trap of, it's either 1 plus 3 or 2 plus 2. So basically, 2 positive numbers, the sum is 4, and you want the sum of the cube of the first. So you want x cubed and the square of the second to be as small as possible. So I'm going to call that, I don't know, a, for lack of anything else. So I don't know what that equals to, but I want to minimize this. So if I want to minimize this, I need to basically differentiate it and set it equal to 0. So therefore I need the derivative of a with respect to, and there's the problem, and put it equal to 0. You basically can't find the derivative of a. I suppose you could find the derivative of a in terms of x by doing implicit differentiation, but then you're going to have a's and x's and y's, and you're not going to get anywhere. So I basically want to find the derivative of a with respect to one letter. So I'm going to choose x in this case. Now, why have I chosen x? Basically, this is a little bit of like a simultaneous equation. And this is where I mean that it's slightly more difficult than normal maths. Can I use this first statement here? Can I isolate a letter and therefore find an expression for a only using one letter? Which is, I suppose, what we have been doing in normal maths. Now, do I want to replace x or do I want to replace y? Now, y is squared, so I prefer to replace y. So if I go from number 1 over here, this implies if I replace y, y is equal to 4 minus x. So therefore, another expression for a could be x cubed plus 4 minus x squared is equal to a. Now, multiple ways that you could proceed here. You could multiply that out, but don't forget this is AP Maths, and therefore you can find the derivative of a with respect to x, because you're welcome to use the chain rule and the product rule and the quotient rule. So if I find the derivative without multiplying out, the derivative of x cubed is 3x squared. And now the derivative of this term here, this is going to be the chain rule. So it's plus, bring down the 2. So this is 2. This is 4 minus x, leave the inside alone, subtract 1. Multiply by the derivative of the inside, which is negative x, because 4 is a constant, so multiply by negative 1. Now basically they want you to minimize this. So I'm going to set it equal to 0, and I'm just going to now multiply this out. So I get 3x squared. I get, so basically this is minus 2, so I get minus 8. And then this is minus 2, so I get plus 2x. And basically that's a quadratic equation. Don't forget again, this is AP Maths. So please do not solve any equation by factorizing. Basically, I just pick up my calculator, I go mode 5. Don't forget that this is A, there's B, and there's C. So just don't make that mistake. And I put that in my calculator, I show absolutely no working. And I get 2 answers. I get x is equal to 4 over 3. Or I get x is equal to negative 2. Now let's work out y, and then let's just figure out, is this possible? Oh, hey, hang on, just one moment. I don't have to work out y and then see if both of them are possible, because it said positive. So that is not possible. So what is y? Well, if the two numbers have to add together to give me 4, 4 minus 4 over 3 is 3, and no, not 3, 2 and 2/3. So I just did this in my head because I quickly minused. I could actually do this using a improper fraction. So, or you could say 8 over 3. Now, do you see, I would never have guessed those as the random 2, you know, because it could be any real number. So most importantly, don't start guessing. Okay, cool. So that wasn't actually nearly as bad as I think it looked like it was. Okay, let's try another one. This is a pretty cool question. Great AV Math question. A holiday resort has a large rectangular pool, as illustrated below. AB is equal to 75 meters, which means that DC, because this is a rectangle, is also 75 meters. AD is equal to 30 meters, so this is 30 meters. A boy can swim at a rate of 1 meter per second. So this is our swimming speed. And he can run at 1 2/3 meters per second. Now, I don't like 1 2/3, it's quite annoying. So let me rather write it as a improper fraction. He starts his swim at A. So for this portion here, he starts to swim at A and he swims to point P. So in this part here, his speed will be 1 meter per second. Then he runs from P to C. So in this point here, in this kind of section there, his speed is equal to 5 over 3 meters per second. It takes him 2 seconds to get out of the pool, which is obviously at P there. So there's 2 seconds of extra time there. Let dP be equal to x. So if this is x, would you agree, I hope, that then this is 75 minus x. The total time is t seconds. And our first question, question A, says, write down an equation for the time t in terms of x. Now, I think the first really important thing to figure out is what is the equation for time. So we'll all know that speed is equal to distance divided by time. Therefore, basically, those can trade positions. So therefore, time is equal to distance over speed. So basically, I need the distance for each of these legs. I have the speeds. They're given to me. So what is the distance? So my first port of call is to figure out what's this distance here. Now, they haven't told me, but this is a rectangle. So this is a right angle triangle. So my distance from A to P, using Pythagoras' theorem, would be, or you could just use distance formula, I suppose. Maybe, let me rather say it like this. So the distance from A to P squared would be equal to 30 squared plus x squared, and that's Pythagoras. And therefore, the distance from A to P is equal to the square root of 900 plus x squared. So therefore, when I use my time in a second, I'm going to go distance divided by speed. I already have the distance for the second part of the journey. Let me use this one, which is there, because that's 75 minus x. So it is fairly easy for me to figure out the total time. So I'm going to say time. Now, don't forget it's distance divided by speed. So for the first, distance from A to P is equal to the square root of 900 plus x squared. The good news is my speed was 1 meters per second, so that's actually going to be a fairly easy fraction. Then that second bit was the distance was 75 minus x, and I'm going to divide by a speed of 5 over 3. And then don't forget they said that he took 2 seconds, did it say? I hope it said 2 seconds. It did 2 seconds to get out of the pool. So there's an expression for t. Now, I probably would want to simplify that, only because I swear in the next question I'm going to have to work with that. So the first term I can't really simplify. It's just 900 plus x squared, although if I'm going to differentiate, I'd change that to an exponent of a half. And then basically I need to divide 75 by 5 over 3. So I would probably now split this by going 75 divided by 5 over 3, and then x divided by 5 over 3. So if you divide 75 by 5 over 3, basically you're multiplying by 3/5. I hope that makes sense because it's tip and times. So I get 45. And again, it's tip and times. So when you divide by 5 over 3, you multiply by 3 over 5. So this is 3 over 5x. I hope that makes sense. And then there's the plus 2. So there we go. There's an expression for my time. So now my question in question B says, can you determine the value for x for which the time is a minimum? So basically I'm going to have to differentiate and set equal to 0. So let's just rather change this to something which is a little bit more easy to differentiate. So this is to the power of half. This is 45 plus 2, which is 47. And this is minus 3 over 5x. So what is t dashed, or the derivative of t with respect to x? First term is a quotient rule, so a half, 900, leave the inside alone, subtract 1, multiply by the derivative of the inside, which 900 differentiates to nothing, x squared to 2x. 47 differentiates to nothing, and minus 3 over 5x is just minus 3 over 5. Don't forget to explicitly show that you're making your derivative equal to 0. And so this now starts to become a little bit tricky, but basically my 2's would cancel. So I get x, and I'm just going to take this to the bottom. And I quite like square roots because I'm used to solving equations with square roots. So I'm going to do that, and this is minus 3 over 5. Okay, what would I do now? Well, I'd probably multiply out by that root, really. So 0 times the root is 0. If I multiply by that root there, it disappears. So I basically get minus 3 over 5 times by, and then this root. Now, I would probably also, in this case, multiply by 5. Make my life a bit easier. So still 0, multiply by 5, so it's 5x minus 3 root 900 plus x squared. Now, we haven't solved anything like this type of equation. I can't use my calculator at the moment because that's not quadratic, but it is a type of surd. And so I would probably bring the 3 to this side and my root, and then square both sides and see how it goes from there. It is a bit of a weird question. And now I'm running out of space. So I would probably now square both sides. It just kind of makes sense to me. And if I go up here, if I square 3, don't forget the 3 is not under the root, so that's 9. And then the square root disappears. And that's going to equal 25x squared. Now, the good news here is this actually just does become a quadratic equation. So 9 times 900 is a bit big, that's 8,100. Plus 9x squared equals 25x squared. The other good news is that this doesn't have any x values, and so the easiest way to really solve this would just be to isolate your x squared. So 8,100 divided by 16, which isn't a particularly nice number, so if you leave it as simplest fraction form, it's 225 divided by 4 equals x squared. Now, yes, technically you'd have to do plus or minus, but you're looking at a distance here, and so you could just square root that. You wouldn't have to worry about the plus or minus because distance can't be negative. So I get 22.5 meters. So really nifty question. I mean, the whole setup of this question is really cool. And then even solving this equation is quite nice because it involved a kind of weird surd that we hadn't seen before. So a really good AP Maths question. And I think our last question is determining the minimum time. Now that's fairly easy because now that we have x, here's an expression for time. So I probably, because it's AP Maths, wouldn't even show any working. I would just substitute 22.5 into my calculator. And even better, I would use 22.5 as my answer. So I literally would just use the answer button. Just be careful that you put it into the time and not the derivative of time. So I just put 22.5 as my answer and put it in my time, and I got 71 seconds. So 1 minute, 11 seconds, or just 71 seconds. So again, really love that question. What a great question. Okay, this is also a pretty nice question. Determine the dimensions of a rectangle with the greatest area. So basically, we need to be maximizing the area. So the moment I see greatest area, if I stop reading the question and I look down at what they've given me a length of x and a breadth of y, which immediately means I am maximizing xy. Now we know from maths and we know from doing previous questions, you can't have two letters, and so I need to be able to isolate y at some, isolate y or x at some point and sub in here so that I get area in terms of one of these. So how is this going to be possible? Well, the second bit of information they've given me is that this rectangle is inscribed, which means its four vertices touch the circle, and the circle has a radius of 10 centimeters. So if I just draw in a whole bunch of radii to help me here, that's 10, that's 10, that's 10, that's 10. This is a right angle. So is there any relationship here between x and y? Now, after looking at this for quite a while, because it did take me some time, the only thing that I can see at the moment that can help me is to possibly use Pythagoras again. So to connect x and y through Pythagoras. So Pythagoras' theorem would have said that x squared plus y squared is equal to my, in this case, it'll be my diameter, which is 20 squared. Now, from here on, it doesn't really matter who you're isolating, x or y. I'm going to isolate x just because I'm so used to it. So basically, it's the square root of 400 minus y squared, which means I can now write an expression for area, but only using one of the letters. Now, I could have isolated y and then substituted that in, but I don't know why. I just chose isolating x. So I get 400 minus y squared, and this is times by y. And you'll notice that I can't really do much here other than use the product rule, because there's this 400 minus y squared has an exponent of a half, and I can't distribute that a half. I can't multiply the y in. I suppose I could multiply the y in if I think about it. Now that I'm thinking about it, there's two routes that you could go here. You could put this in by saying, right, it's the root of 400 y squared, because you could square root that y squared and get y, and you could do that, because if you think about it, this would become the square root, and you'd factorize out y squared, and you'd make it 400 minus y squared, and then you'd kick this out. And to be honest, that's probably a lot easier than doing the product rule, so why not? So if we went with that, so if we decided to do that as opposed to the product rule, we would then have that it's 400 y squared minus y to the power of 4 to the power of a half. So what's the derivative of the area with respect, in this case, it's y. So this is the chain rule. So bring down the half, leave the inside alone. So y squared minus y to the power of 4, subtract 1, multiply by the derivative of the inside, which is 800y minus 4y cubed. Now, I'm not particularly loving the look of this because this doesn't look like a particularly nice equation, but anyway. So let's just quickly check that. Bring down the half, leave the inside alone, subtract 1, multiply by the derivative of the inside. Very importantly, explicitly show that that's equal to 0. This is all a product, so I suppose that it might be a good idea for us to say, well, can't I halve the 800 and halve the 4, basically, because it's a half of 800. If I do distribution, so a half of 800 is 400y, and a half of 4 would be minus 2y cubed. Now I have a wonderful feeling, don't forget that you're going to take this to the bottom, so this becomes divided by, I'm not too sure why I'm making this a root, but anyway. The good news here, and this is why I think this was much easier to do this the method of avoiding the product rule, is that basically I can multiply by the denominator and it disappears, because a fraction can only equal 0 when the numerator equals 0. So basically 400 minus 2y cubed equals 0. Again, this is AP Maths. So you just pick up your calculator, you go Mo 54. Just be a little bit careful. This is A, this negative 2 is the A. B is equal to 0 because there are no y squareds. This is C, and D is equal to 0. So you just punch that in your calculator. 400, 0 equals, and I get two values, or a couple of values. I could get 3, so let's check. I get, if I round it to 2 decimal places, I get 14,14 centimeters, and my other one is negative 14.14, and the other one is 0. So not obviously going to be that one, so cross that out, or not going to be 0, because then it wouldn't exist. Now, if it didn't exist, that would lead to the minimum area, because the rectangle, I suppose, would be entirely flat. So it wouldn't really exist as a rectangle, it would be a line, and so it wouldn't have an area. So this means we have to be working with 14,14. Now, if you have a look, it said, can you get the dimensions? And so you do need to find x. And so x is equal to the square root of 400 minus that. So I should have said minus that squared, and guess what? I get 14,14 centimeters. So basically what they're saying is that the maximum area will exist when this is actually a square, which is pretty cool. So the maths behind this, in terms of actually maximizing and minimizing, is not what's difficult here. What's difficult here, sorry, let me undo that. What's difficult here is that getting to the equation is the hard bit, and actually sometimes solving these equations can be a bit tricky, but we have an awesome AP Maths calculator. Cool, well done.